Hi again, it's Dr. Niffler. Today we're going to talk about the review for exam 3. Starting on question 1. A relation in x and y is given. Determine if the relation defines y as a one-to-one function of x. Remember that to be one-to-one, the y's can't repeat. And so when we're looking at the ordered pairs, we see we have 314, we have 723, and we have 923. Because the y's repeat, this is not a one-to-one function. Question 2. Determine if the relation defines y as a one-to-one function of x. When I look at that relation, first thing I see is it does not pass the vertical line test. That vertical line crosses twice. So first of all, it's not a function. And so we don't even have to go see if it's a one-to-one function. I'm just going to circle it does not define y as a function of x. It's because it's not a function. Number 3, a one-to-one function is given. Write an equation for the inverse function. Okay, they told us that y equals 9 minus x over 7. To find the inverse, we need to switch the x and y. So I'm going to write it as x equals 9 minus y over 7. And now I need to get the y by itself. To do that, I'm going to multiply both sides by 7. So that cancels. Now I have 7x equals 9 minus y. I'm going to go ahead and move the y to the left so it becomes a positive y. So I'm going to add y to both sides. Those are gone. I have 7x plus y equals 9. The last thing I need to do is get the 7x to the other side. So I'm going to subtract 7x from both sides. And I'm left with y equals 9 minus 7x. That's my inverse. 9 minus 7x. Question 4. The graph of a function is given. Graph the inverse. We have to remember that a function and the inverse, they switch the x's and y's. So here on the function, I know 3 points. I know the point 4, 0. I know the point 3, negative 5. And I also know the point negative 2, negative 6. Now, for the inverse, I'm going to do it in green. Points on my inverse will be 0, 4. Now, where is that? 0, 4, right there. I'll have the point negative 5, 3, negative 5, 3. And I'll have the point negative 6, negative 2. Negative 6, negative 2. So here in green is my inverse. And I can do a double check because this line y equals x should act as a mirror. You should see the same thing on one side, which is the function, as you do on the other side, which is the inverse. So the part in green is my inverse. Question 5. Graph the function and write the domain and range in interval notation. My function is y equals 6 to the x. y equals 6 to the x. Okay, I'm going to go get some points. This is an exponential function. My three favorite x values are -1, 0, and 1. When x is -1, 6 to the -1 is 1/6. When x is 0, 6 to the 0 is 1. And when x is 1, 6 to the 1 is 6. So I have 3 points. My first point is -1, 1/6. It's going to be way down here. -1, 1/6. Another point is 0, 1. And the last point I have is 1/6. And when you hit those, when you plot those points, it should give you something that looks like that. Okay, domain and range. The domain of an exponential function is always all real numbers. Always. -infinity to infinity. My range, y values. The range starts at 0. It cannot be 0. And then it goes all the way up to infinity. Those are the y values. It starts here at 0 and all of those y values. But it can't be 0 because remember, you've got a horizontal asymptote there at the axis. Question number 6. Graph the function and write the domain and range. Your function is y equals 1/4 to the x. Okay, my three favorite x values. This is an exponential function again. -1, 0, and 1. You can use your calculator. 1/4 to the -1 is 4. So my point is -1, 4. When x is 0, 1/4 to the 0 is 1. My point is 0, 1. And then we have 1/4 to the 1, which is just 1/4. So my point is 1, 1/4. Notice that the base is between 0 and 1, so this is going to be exponential decay. My points are going to be -1, 4, 0, 1, and 1, 1/4. So exponential decay looks like that. Again, this is an exponential function, so the domain of an exponential is always all real numbers. And my range, because I have a horizontal asymptote here at y equals 0, my range is going to be from 0 to infinity. Number 7, use the function below to answer the following questions. They gave me y equals 2 to the power of x minus 4, and then -2. Part A says to use transformations of the graph y equals 2 to the x to graph the given function. Okay, that's your parent function, y equals 2 to the x. Question 8. The atmospheric pressure on an object decreases as altitude increases. If A is the height in kilometers above sea level, then the pressure P of A in millimeters mercury is approximated by P of A equals 760 e to the power of -0.13 A. That's our function. That's given to us. It wants us to find the atmospheric pressure at sea level. Okay, A is the height above sea level. So at sea level, A is going to equal 0. So we need to find P of 0. On our calculator, we're going to type in 760 e to the negative 0.13 times 0. 760 e to the negative 0.13 times 0. I get 760. Part B says to determine the atmospheric pressure at 5.489 kilometers, which is the altitude of Mount St. Elias. Round to the nearest whole unit. So you're going to find P of 5.489. On your calculator, you're going to type in 760 e to the negative 0.13 times 5.489. And let's see what we get. 760 times e to the negative 0.13 times, what was that number? 5.489. I get 372.3. Now be careful. It tells you to round to the nearest whole unit. The nearest whole unit would be 372. That's your answer. Number 9. Write the equation in exponential form. Remember we had Ben and Benny. So to convert from logarithmic, we're going to start at the base and say b to the e equals n. So over here, m to the p equals n. M to the p equals n. That's converting from logarithmic to exponential form. Question 10, write the equation in logarithmic form. So now they've given you exponential form and you have to go back to logarithmic. So you're going to do the base and then circle around. So you're going to write log base A of the number B equals 1. Number 11, graph the logarithmic function. Y equals log base 6 of x. Plot 4 points and an asymptote. Okay, for a logarithmic function, y equals log base 6 of x. Now you have favorite y values. I'm going to do -1, 0, 1, and 2. Okay, let's go look at the calculator. I'm going to go to y equals, okay, log. Remember the two buttons down on the black buttons are log base 10 and natural log is log base e. So I'm going to need to go to math and arrow up to where it says log base. I'm going to hit enter. It's log base 6 of x. And I'm going to do a zoom 6, a zoom standard. Now don't forget that that doesn't just start right there in the midair. It's actually a vertical asymptote at x equals 0. But this will give me points. If I go to my table set, which is above window, so second window, and I want to start it at -1 and go up by 1, then I can go look at my table. Okay, when x is 1, my y is 0. So there's a point. I have 1, 0. Let's look at another point. I have the point 6, 1. I go all the way down, 6, 1. So there's another point. Now for the 2, it's going to be 6 squared. So that's going to be 36. And for the negative 1, it's going to be 6 to the negative 1, which is 1/6. This was actually 6 to the 0, which was 1, and 6 to the 1, which was 6. But you can get those on your calculator by finding points. Okay. Go plot those on your ALEKS. So you've got 1/6, comma, -1, 1, 0, and 6, 1. And then you would have 36, comma, 2. It should graph that. Now, it also wanted you to graph the asymptote. You're going to go grab that line, and you're going to do an asymptote at x equals 0. Number 12, use the function below to answer the following questions. The function is a logarithmic function, base 3, of x plus 2 plus 5. So you're going to use the parent function to go graph the function they want you to graph. That plus 5 moves it up 5. That x plus 2 moves it left 2. So we can go grab a point. Let's grab the point 1, 0. And I'm going to move it, what did I say, 5 up and 2 left. 1, 2, 3, 4, 5, 1, 2. Now, where is that asymptote going to move? That asymptote has to move 2 to the left. So it's going to be here at x equals -2. And it should automatically graph it like so. Okay, your domain and range. Your domain, what x's is this logarithmic function going to have? Because that vertical asymptote is at x equals -2, the domain will be from -2 to infinity. The range keeps going this way and it keeps going that way. The range will be all real numbers. Remember that the domain and the range of exponential and logarithmic, they switch. So the domain of an exponential function is always all reals. So the range of a logarithmic will always be all reals. Okay, what else did they want you to do on this problem? What's the vertical asymptote? So that vertical asymptote there in pink, the vertical asymptote is at x equals -2. Don't just type -2, that's wrong. You have to give an equation, x equals -2. Number 13, use the product property of logarithms to write the logarithm as the sum of logarithms. Then simplify if possible. Assume the variables represent positive real numbers. Okay, I'm going to remind you that the log of a times b can be written as log a plus log b. Knowing that information, what is the log base 5 of r plus s times t? You're going to write log base 5 of r plus s plus log base 5 of t. You don't have a property that says you can do anything to that. You just leave that alone, log base 5 of r plus s. Question number 14. Use the quotient property of logarithms to write the logarithm as a difference of logarithms. Then simplify if possible. Assume the variables represent positive real numbers. Okay, for this problem, you're going to have to remember that the log of a divided by b is written as the log of a minus the log of b. So in the problem they give you, all you've got to do is add the bases. So you're going to have log base 11 of a minus log base 11 of b. Number 15. Write the logarithm as a sum or difference of logarithms. Simplify each term as much as possible. Assume the variables represent positive real numbers. Okay, the only other rule you need to remember is log of m to the n power. That n that's an exponent can sprout legs and walk out front. So you get n times log m. All right, so let's break this down. Log base 9 of p to the 5th over m times n. I'm going to get rid of that division first by doing log base 9 of p to the 5th minus log base 9 of m times n. Okay, that p to the 5th, I don't like that exponent there. I'm going to bring it out front. So I get 5 times log base 9 of p minus, all right, I see a product in there. I can split that up as a sum of logs. So I'm going to put a bracket here and do log base 9 of m plus log base 9 of n. Now I'm going to distribute that negative that's out here in front of those brackets. My final answer will be 5 log base 9 of p minus log base 9 of m minus log base 9 of n. Question 16. Write the logarithmic expression as a single logarithm with a coefficient of 1. In other words, it wants you to go backwards and write this whole thing here as one logarithm. The first thing, I'm going to put that 3 back up as an exponent on that m. So I have log base 5 of m to the 3rd plus log base 5 of n. Now, when I'm writing one logarithm, what am I going to do with that plus? It's going to become log base 5 of m cubed times n. And you're done. Number 17, solve the equation. 3 to the x equals 27. Now, I notice that 27 is a power of 3. So I can rewrite that as 3 to the x equals 3 cubed. So x must equal 3, right? X equals 3. The solution set is the set containing the number 3. Another way to do this is to take the ln of both sides. So you start with 3 to the x equals 27. You take the ln of both sides because the x is in the exponent. If you take the ln of both sides, that x can sprout legs and come out front. X times ln 3 equals ln of 27. And now you divide both sides by ln 3. You're left with x equals ln 27 over ln 3. If you were to check that on your calculator, ln of 27 divided by ln of 3. Don't forget your parentheses. You get 3. Now, my math lab should accept that as well. I'm not 100% positive, but it should. Sorry, not my math lab, ALEKS. But that's also just the number 3, right? You checked it on your calculator. Same thing with number 18. Solve the equation. Simplify the answer as much as possible. I notice that 8 is a power of 2. So I can write 2 to the negative 2a plus 11 equals 2 to what power? Okay, 2 times 2 is 4. 4 times 2 is 8. So 2 cubed is 8. I can get rid of the bases, and I've got negative 2a plus 11 equals 3. Subtract 11 from both sides, and I have negative 2a equals negative 8. Dividing both sides by negative 2, I get a equals negative 8 divided by negative 2 is 4. The solution set is the set containing the number 4. Number 19, solve the equation. Write the solution set with the exact values given in terms of the common or natural logarithms. Also give an approximation to 4 decimal places. Okay, 7 to the t equals 59. The variable's up in the exponent, so the process says to take the natural log of both sides. When you do that, that exponent gets to walk out front. So I have t times the natural log of 7 equals the natural log of 59. How do you get t by itself? You want to divide both sides by the natural log of 7. All that remains on the left-hand side is t. So you get t equals the natural log of 59 over the natural log of 7. That's the exact solution. To find the approximate, we're going to do the natural log of 59 divided by the natural log of 7. Okay, to 4 decimal places, your answer is going to be 2.0954. Because it's a 3 after the 4, it's not a 5 or bigger. We're just going to keep the 4. So my approximation is 2.0954. Number 20, solve the equation. Write the solution set with the exact values given in terms of common or natural logarithms, and also give an approximation to at least 4 decimal places. Okay, the m is in the exponent on that e. So our goal right now is to get the e to the 2m minus 1 by itself. First thing I need to do, so 7e to the 2m minus 1 minus 3 equals 11. I need to add 3 to both sides. I end up with 7e to the 2m minus 1 equals 14. The 3's are gone. Okay, next thing, what do I need to do to get the e to the 2m minus 1 by itself? I need to divide by 7 on both sides. So now I have e to the 2m minus 1 equals 2. The m is in the exponent. It's isolated, e to the blah. Now I can take the natural log of both sides. That whole entire exponent comes out front in parentheses. 2m minus 1 ln e equals ln 2. Hopefully you remember that the natural log of e is 1. If you don't, you could divide both sides by natural log e. So you have 2m minus 1 equals, and on your calculator, if you were to do natural log of 2 divided by natural log of e, natural log of e, that's the same as natural log of 2. Okay, so that's just ln 2. To get m by itself, add 1 to both sides. So 2m equals 1 plus ln 2. Now divide both sides by 2. So your answer that you type in will be 1 plus ln 2 all over 2. Your approximation, I'm going to go do a fraction. Oh, hold on. 1 plus ln of 2 all over 2. I get 0.0466. 0.4657. The 7 is bigger than 5, so it's going to bump that 5 up. 0.8466. Question 21. Switch to another color. Solve the equation. Write the solution set with exact solutions. Okay, you have log base 3 of 9x minus 4 equals log base 3 of 2x. Because there's a log base 3 on both sides, and there's only one of them on both sides, I can essentially get rid of the log base 3's. What you're doing is actually exponentiating it, 3 to the log base 3, but that's it. We can get rid of the log base 3's. So if we know 9x minus 4 equals 2x, we need to subtract 9x from both sides. We have negative 4 equals negative 7x. Then we can divide both sides by negative 7. And we get x equals 4/7. If I plug in 4/7 for x, because I've got a log equation, will I still be taking the log of a positive number? So what is 9 times 4/7 minus 4? 9 times 4/7 minus 4. That's a positive number. I'm okay. And then 2 times 4/7 is 8/7. That's a positive number. So my solution set is 4/7. Number 22, solve the equation. Log base 3 of 4x minus 9 equals log base 3 of 3x. Again, we're doing both 3 to the power of. And all that does is get rid of the log base 3 on both sides. So I have 4x minus 9 equals what? Just 3x. If I subtract 4x from both sides, I'm left with negative 9 equals negative x. How do I get x by itself? I need to multiply or divide both sides by negative 1. 9 equals x. If I check that equation and I plug in 9 for x, 4 times 9 is 36 minus 9. That's a positive number. 3 times 9, that's a positive number. So the solution set is just the set containing the number 9. Number 23, solve the equation. Write the solution set with exact solutions. Log of 9x minus 8 equals 2. Because there's no base written there, it's understood to be base 10. That's the common log. So log base 10 of 9x minus 8 equals 2. To solve the logarithmic equation, I need to convert that to an exponential equation. Remember how to do that? We're going to write 10 to the power of 2 equals 9x minus 8. Now, what is 10 squared? That's 100 equals 9x minus 8. How do you solve for x? First thing you do is add 8 to both sides. So 108 equals 9x. To get x by itself, divide both sides by 9. So you're left with x equals 108 over 9. Does that simplify any? 108 divided by 9. Oh, look, it's 12. Okay, x is 12. So the solution set is the set containing the number 12. Number 24. Solve the logarithmic equation. Write the answers in exact simplified form. Okay, on this one, the left-hand side has the difference of 2 logs. I don't like that. I want just 1 log on that side. So how do I combine it to be 1 log? I'm going to do log base 2. Since I have a subtraction right here, I'm going to turn that into a division and do 9 over k plus 8. Now that's supposed to equal 3. I don't know how to solve logarithmic equations unless I convert it to an exponential equation. So let's go play the circle game. I'm going to do 2 to the 3rd power equals 9 over k plus 8. What is 2 cubed? 2 times 2 is 4 times 2 is 8 equals 9 over k plus 8. I'm going to multiply both sides by the denominator, k plus 8, and my fraction will be gone. Now, over on the left-hand side, I'm going to have to distribute that 8. 8k plus 8 times 8 is 64 will equal 9. I'm going to write that up here. 8k plus 64 equals 9. Okay, what's next? I want to get the k by itself. First thing I need to get rid of is that 64. So instead of adding 64, I'm going to subtract 64. But I have to do it from both sides. 8k equals 9 minus 64 is negative 55. To get the k by itself, divide both sides by 8, and I'm finished. K will equal negative 55 over 8. Now, do I have to be careful with that? I've got to check it and make sure I'm not taking the log of a negative number. Log base 2 of 9, that's good. Log base 2 of negative 55 over 8 plus 8. Negative 55 over 8, and then plus 8. Oh, cool. That's a positive number. So that solution worked. The solution set is negative 55 over 8. Number 25. We saved the best and longest for last, right? Okay, fluorodeoxyglucose is a derivative of glucose that contains the radionuclide fluorine 18. A patient is given a sample of this material containing 300, and I have no idea what that unit is, but they're given 300 units of it, of radioactivity. The patient then undergoes a PET scan to detect areas of metabolic activity indicative of cancer. After 174 minutes, 1/3 of the original dose remains in the body. Write a function of the form Q of t equals Q naught, so the initial amount, e to the negative kt to model the radioactivity level of fluorine 18 at time t minutes after the initial dose. Round the value of k to 5 decimal places. Do not round intermediate calculations. Okay, here we go. Q of t equals Q naught e to the negative kt. We were told after 174 minutes, there was 1/3 of it left, right? Let's see. After 174 minutes, 1/3 of the original amount is left. So if you start with 1, your Q naught is 1. After 174 minutes, that's going to be time, you're going to be left with 1/3. If you start with 1 unit, after 174 minutes, you have 1/3 of a unit left. Okay, 1/3 equals e to the negative 174k. It's isolated. The k's in the exponent. We're going to take the natural log of both sides. When you do that, that exponent comes out front. So I have natural log of 1/3 equals negative 174k times the natural log of e. But the natural log of e is just 1. So now I need to divide both sides by negative 174. My k, what is that number? Natural log 1/3 divided by negative 174. Divided by negative 174. My k is 0.00631. 0.00631. So my equation, Q of t, it starts with 300 units, e to the negative k, 0.00631 times t. That's the answer for part 1. Now for part 2. What is the half-life of that substance? Round to the nearest minute. Okay, to find the half-life, my initial amount was 300. So when half of it is gone, how much remains? 300 divided by 2, 150. So 150 equals 300 e to the negative 0.00631 t. If we start with 300, how long does it take for half of it to go away? So how much do we have left? We'd have 150 left. We need to go solve for t. Divide both sides by 300 to get to e by itself. 150 divided by 300 is 0.5 equals e to the negative 0.00631 t. How do we get that exponent to walk out front? We take the natural log of both sides. Natural log of 0.5 equals negative 0.00631 t times the natural log of e. But what is the natural log of e? It's just 1, so that goes away. Divide both sides by negative 0.00631. And what is t going to be? T will be natural log of 0.5 divided by negative 0.00631. I get 109.8. 109.8. What does it tell you to do for the answer? Round to the nearest minute. So what is that going to be? 110? So there's your answer for part 2. And that's it. I strongly encourage you to, hopefully you've worked this one time with your notes, and now put everything away and go take the entire review again using just your brain and a calculator. Good luck.